So thanks a lot for the invitation. I want to speak about some results regarding secure-reliable firewall system based on MINIX3. That is some work which has been performed in the last 10 years after my fantastic time in this group. I went to Berlin, I get professorship at the Technical University of Applied Sciences, now Hochschule für Technik, and we continued to work in this field and we learned a lot, but as in the other talks, the problems of developing system software is always more challenging than you have expected even after experience of many years. First, take a look at the main definition of MINIX3. I'm taking the points of from Andy's page. MINIX was really targeting very different fields, but on the other hand, I'm taking a closer look and saying...
Ruedi, could you use the mic?
Oh, sorry. Okay. As we see here, and as we have in the previous talk, Internet of Things or embedded systems will get more and more important for our society. I would go even further and say the question to have a secure small systems, secure trusted systems is very important for our computer science community, but if we put more and more devices which are relevant for a peaceful and good situation in the community, we have to take care about the security of embedded systems, and we have to take care about the openness of these embedded systems. And I think these are two problems which should be addressed in a more efficient way. A lot of developments we actually discuss in the field of secure boot and UEFI constructions leads to really a lot of security problems and a lot of problems regarding competition between companies. And so I think MINIX will also, from this perspective, a very interesting choice. As mentioned in the previous talk, the application should have a high reliability. We have a strong focus on embedded systems. And the last point is something I want to make some additional remarks. Education, maybe some of us are professors and they are interested to give nice operation system courses. But nevertheless, I think it's a fantastic metric for having systems which are understandable. If a system can be taught in one lesson, I think this is a good metric for having a system which is not too complicated to explain. So, second point is, if we have a system which can be taught in computer science courses, a lot of students will have qualification on this field. To make a very clear statement, this point that a system is good for education and even is good for education, one course for us is a good metric for security in the field of simplicity. It's simple enough to teach it to well-motivated students. And second, that if we teach it to a group of students, we will have more people with this knowledge. And I think if we come to a situation where embedded systems really are responsible for a lot of development in economic and other aspects of our society, I think it's important to realize that this idea to have an educational friendly system is really a very strong statement. Second, to be more technical, is POSIX compliant. Regarding the questions of licensing, it's under the BSD license. We had a discussion with Andy about using GPL or BSD, and I'm in favor of GPL, but Andy has a lot of good argumentation that it might have been the better choice to use BSD, and I think for a lot of people in the industry is a BSD like license additional plus. We have from the first versions completely TCP/IP support, and coming to the main properties which makes Minix a good choice for firewall and other secure application. The device drivers run as user processes, and we have a high degree of fault tolerance. And one of the first results was a diploma thesis of my student Brian Schüler at the Technische Fachhochschule Berlin, and this time we have changed our name. And it was analysis and porting the Netfelder framework to Minix 3. And I'm a bit proud that this student has won a prize from the German Society for Applied Research, about 3,000 euro, which is a good thing for a young student, and I'm very happy to do this. And what was the idea? The idea was really taking the Netfelder framework from Linux and port it bug by bug to a Minix system. Yeah, I make a statement bug by bug, because that was a critic of a lot of people which say if you want to do something new by using some strange C code. And to be very clear, there have been several security violations in the Netfelder code. This has been developed by one friend of mine and other people which take great care. Nevertheless, they had some security violation which brought us to an idea to compare these security problems in a field of Minix 3 solution and in the field of Linux solution. To make a graphical representation, what was the idea? And in Linux systems, the firewall code living directly in the kernel. In the Minix space, it's a process in user space. And this is a point where I have not big problems to explain the research idea, part of this research idea, to non-computer science people. I just ask, if you run a normal post office and you have to check suspicious packets, what are you doing? You make the decision to have, I have a suspicious package, so put it to the main building and put it on the table and open it. It's much faster than any other solution. Or put it in a separate room in the garden and activate a robot to play with this stuff. That is more involving, but in a crash scenario you have bigger problems. And this is, if you take a discussion with the normal post office, it's they would smile at it. And I have to acknowledge also that this example has been also borrowed from Andy, which makes the statement that bringing, for instance, closed source graphical drivers into your kernel is something like you go to the airport and I have a sealed package. I don't tell you what's inside, but install it directly in the cockpit. You shouldn't do it even if you have good social engineering skills like my previous presenter. I think it's very understandable, and even in this graphic you see if a firewall crashes, the whole Linux crashes. Or making a small explanation what can happen. And one problem is, additional to the high complexity of monolithic kernel, is that they usually use C, and C means that every problem can really lead to a disaster. And there are, from a hacking perspective, two kinds of attacks. One is a crash attack. What happens with a Linux Netfelder? The whole system crashes. Even more scary is if you are a skilled young hacker, you can try to execute code, and this is a complete nightmare in a Linux scenario. You own the whole system. You can deactivate logging, you can deactivate other systems, you can try to attack other computers in the local network, so it's a complete nightmare. And if you just compare this situation really a bit by bit to the net filter scenario, you see what happened there. Funny thing is, if you have a crash attack, then you have a crash process. And this is also a nice statement from ND as presented, I think, on FOSGEM for some years ago, that he's showing that a main function printer driver or a main function network card is only slowing down the system for some percent, because we have here this really Canadian server which works here in a very fine mode. So if we have just a crash attack, it's not unlikely that the system will not suffer any remarkable damages. Not so nice is if the attacker can execute code. But even there, the difference, I think, even more interesting, because in this situation we have our own user process. Nevertheless, there are other processes which can take care of logging, which can take care of anything else, which can inform the administrator that something strange happened. In the scenario of Linux, we have the situation that if somebody owns a system, he can also deactivate logging, he can manipulate everything there. In Minix, we have really isolation. If an attacker can execute some code, it's their own user process. He can deactivate the firewall, but he cannot attack other security partners in the system. And I think this is really a main difference. Here is isolation on many levels helpful to build up much more secure systems. We have also here a whole list of reliability properties of Minix from the Minix page, and here you see that additional to the isolation, a lot of really generic security features are included in Minix. And I think that, opposite to some statements of the previous talk, if I would have the wish on Minix, was not more complexity. It's a good thing on the security side to have very limited systems. I know that it's not a friendly statement about people who want to have fascinating stuff with the Minix system. Nevertheless, I think it's a really strong part. Even stuff like fixed length messages and very maybe not so flexible synchronization is something you will really work very hard if you want to have it for security reasons in your system, if it's not provided in the lowest level as we have here in Minix. Second stuff I want to show in a bit shorter way was some thoughts about virtualization. The main idea is Minix does not need a lot of memory. So I think it's an interesting candidate for systems which try to provide this construction to have a firewall and a server on the same machine. There have been a lot of projects, for instance, over many years from ISE publisher in Germany, which presenting this in a Linux environment, and we have tried to make it with two research assistants to test which services can be used by substituting the firewall functionality from Linux to Minix, and this led to a publication on the ISE GE Sicherheitskonferenz in 2010 in Berlin. And this is not so nice like the last slide, but nevertheless, I think it's also an interesting idea. We have a virtualization layer and really provide the whole firewall functionality by Minix there. On the other hand, after preparing my talk, this was a point where I say, come on, you have a system which is a microkernel system, and you put it in another microkernel system responsible for virtualization, and if you go to Ruedi stuff, you have additional some kind of microkernel systems there involved. And so this is a critical question if the cooperation of this several layers will introduce some additional security problems. So, coming to my last statements, I think it's really a very big problem that we don't have a small, secure boot system. At the moment, we have a development which makes me very nervous. You may have seen Windows 10 with secure boot, and I spent the last weekend hours and hours to try to install a modern computer systems with secure boot and UEFI, a non-standard Linux distribution beside of a Windows 10 system. It has costed some hours, and I managed to start every useful systems except of Windows 10 there. To make it very clear, at the moment we have the situation that Microsoft is providing Windows 10 with a totally new business model, so you rent software and with a dramatically change of the update strategy. At the moment we have the situation that combining UEFI, secure boot and trusted computing chip, that we have a situation where all our Linux systems can run if they have a signature by Microsoft. This stuff. And this will really lead to a lot of problems to normal free software development. So I want to make really a business political statement that we need something like a trusted computing base that might be open via system, but if you have really Minix systems which provides a lot of similar stuff and BSD license, I think Minix 3 might be a very interesting candidate if we focus on this secure BIOS, secure booting system. And though this might be a wish from me to the community that we should continue thinking about this kind of solution. Thank you for your attention.
Any questions for the speaker?
Oh, I have a question.
Yep.
So it was only the beginning of your talk, but it also was resonating with the previous speaker. You mentioned embedded systems and low power systems as potentially interesting targets for things like Linux. But there, low power is probably key, and isn't it fundamentally more high power than monolithic systems?
It's interesting. It's an interesting question we have also discussed at lunchtime. I'm a mathematician originally, and so I have the strong feeling if you have a system which is functional, like a Minix kernel, it should be work in a fantastic way on multi-core computer systems. And this is also maybe one of the few things have changed in the last 10 years. You don't have to make the statement that your system is very fantastic with single core computers. Now even most embedded systems have at least 2 cores and mobile phones maybe 4. And so for my deep mathematical feeling, it should be better also from a power consumption standpoint to have a system which is really generically fine parallelism. Nevertheless, I have learned a lot that this mathematical view of the reality not always fits perfectly with the real situations, but this is research and we should continue to do it.
And
I didn't quite understand your comment about Windows 10 and secure boot. Is that a property of the hardware, or that when Windows 10 boots, it can tell that it hasn't been modified?
Yeah, it's a combination about both. Microsoft has requirements to provide a public key from Microsoft in the devices. If you want, as a hardware producer, this logo runs with Windows, you have to embed a public key from Microsoft. And so Microsoft is some kind of a doorkeeper at the moment. And at the moment, Microsoft is the only powerful company which can ensure that their key will be embedded in the systems. And Microsoft can make over the net updates there and say we deactivate other booting programs. And they already did it several times. And so yes, it's a combination between soft and hardware, and this is something we will have discussed. Just discuss a generic way to bring free software without acknowledgement of Microsoft to our systems.
This applies to Linux and BSD and everything, you know.
It's applying to
Other
Linux.
systems,
At the moment they make a dirty hack by signing a group bootloader, but Microsoft can revoke it with one message, and this is not acceptable. If you think about the scenario, Microsoft might be forced to deactivate bootloader which are not acknowledged by Microsoft. This is a really new scenario, and I think we need a small open source systems, and I think MINIX3 can play a role in this game.
But in the end, you say, I understand you very well, if we have EFI or EFI, then we have a dedicated chain where we don't have control till our own running. Yes, if we cannot change the BIOS or we cannot flush it. On embedded systems, we have the advantage, often we can. Now let's go to bigger systems, desktops and what's that. There we often cannot flush the BIOS. So there I understand your risk.
Yes, to be very clear, there are good arguments from the security standpoint that Microsoft say we want to have control what's booting, and we don't want to have really deeply embedded malware. But it really leads to a bit of complication for competition, and also about the question what is if Microsoft makes security failures. And I want to make a statement. I'm very surprised there have been an update from Microsoft which was completely random, and it really was not stopped by the quality control from Microsoft. So we have really a nightmare which has been provided, signed by Microsoft to update on systems, and it's a complete nightmare if you have a similar situation with embedded systems. Yeah, with our normal computer system, we can go there and check what's going on. If you have embedded systems, then we might be in deep trouble.
With embedded systems, you have better chance to get those BIOSes out than normal ones.
On some, yes. On some, definitely not. I think so. Okay.
But are you advocating that Minix will not run on closed source hardware, or are you advocating that there always remain some open hardware on which Minix will run?
I hope that there might be also hardware which is not directly connected to the Windows world. But for the last decade, Windows has brought us to hardware point. I acknowledge that the situation is not so horrible since 15 years ago. Then we can do our own hardware stuff. It's getting cheaper and cheaper, and so there will be hacks around. But nevertheless, it's a dramatic change in the development landscape which happens with Windows 10.
Okay, if there's no more questions, then I'd like to thank the speaker again.